Hey everybody, welcome to Solving Equations Practice Test. It is obviously Christmas time, the semester's wrapping up, and here's what we've got. You might look at this and go, holy cow, 42 questions. This guy must really hate our guts. No, instead, what I thought was day 1, day 2, day 3, day 4, day 5, day 6. If you did this much over the next 6 days, I feel like you would be ready and a master of this stuff. Or at least you would know how you feel. Like, let's pretend this is a thermometer, and you know how like down here is like it's not much, but as the heat rises, if this is 100 degrees or even 100%, right? Like if here's 50 degrees, or aka 50%, if you felt that your temperature was only about here, then hopefully you could figure that out sooner than later, and you wouldn't wait till day 6 to say, hey teacher man, I'll get you some help. I'm not feeling as hot as I'd like to feel, but maybe, just maybe, you would feel boiling hot, and you're like, I'm gonna do awesome on this thing. I don't know. Anyway, so that my recommendation is literally as I've outlined them on this page. And notice that this page is literally packed full of the math problems. I have not given you enough room to do any of these problems. And in fact, I have said, write each problem on a separate sheet of paper. Then solve each equation. Then check your solution by plugging back in. I'm going to do that. I'm going to do it in sections. And by the way, I've written out every single problem, all 42 of them myself, so that if you're like, oh man, I'm not going to do all that, that's so awful, I did it. You can do it. And in fact, I have this broken down by here's day 1, here's day 2, here's day 3, here's day 4, day 5, and so on. Okay? So let's get started. This is day 1. I'm going to zip in here, and I've already written them down, so this isn't AI. I didn't somehow make AI do this for me. I did it, okay? Number 1. In fact, I'll also say I'm going to attempt to teach a lot on, let's say, day 1 and 2. So these will be the longer videos. Days 3 and 4, I'm going to teach a little less. Days 5 and 6, I'm hoping that you're feeling a little more confident and that we can just go into solving mode, okay? So, and if you're like, no, that's not working for me, well, then we'll find out as time goes on. Number 1, 15t equals 60. If you are looking at this already and going, uh-oh, I'm in trouble, I need you to stop. And I need you to immediately do this. I need you to go online to YouTube. I need you to search for this video right here, The Basics. If you're having trouble solving equations, you need to watch this. And you might be looking at this going, oh my goodness, 22 minutes long. This video is already a real long video. You know what? If you really are having trouble like immediately, then you need a little bit of recognition practice. And so this video is in 2 chunks. The first chunk is kind of about is simplifying integers. And if you're like, what is an integer? Okay, well, like -2 plus 11. If you're not sure what that is, go here. If you are like, hey, but what if I had like -7 minus 15? If you're not sure what that is, go here. How about this? If you had 2 minus 9. If you're not sure, go here. Are you noticing a pattern here? I want you to, if you need to, get some of the basics going. And that's about the first half of the video, maybe 2/3. And then the last half, the last third, is about this. It's about saying, hey, listen, we have different types of problems. There's division, there's multiplication, there's addition, and there's subtraction. And you are would benefit from being able to just see it right away and knowing, oh, that's the difference between those two. Like this one has dividing, this one has multiplying, this one has adding, this one has subtracting. By the way, the video has nothing to do with these little smiley faces. I'm just throwing that out there of like, if you're looking at this going, oh no, then I'm telling you, this is where to go, okay? So let's jump back to here. Sorry, it's 5.5 minutes into this and we haven't done any math yet, but we are about to. What's happening is 15 is multiplying t. Was that purple dot there before? No, it wasn't. But you know what else is not there? Not a plus sign, not a minus sign, not a division symbol, not like 15 divided by t. None of that was there. And actually, that dot wasn't there either, but they're trying to say that you have 15 groups of t. And 15 groups of t means that we can divide the groups up. And what we get is the 15s cancel, leaving us with t equals, what is that? 4? 4 times 5 is 20. 4 times 10 is 40. 20 and 40 is 60. So I said that I wanted you to solve them and then plug them in. So here's how you're going to plug them in. 15 times that t, which is 4, does it equal 60? And then, I mean, we already answered that question. Yeah, it's 60 equals 60. So we're happy with this. Number 1 is done. And not only is it done, we like covered it left, right, up, and down. Number 4. And if you're like, wait, number 4, I thought we were doing number 1. Yeah, remember, I'm saying this could be your day 1, okay? And just FYI, these are supposed to be maybe a skosh easier than these, okay? And then down here, these are supposed to be tougher than these up here. And then these are just like random difficulty. They're not necessarily easier than these. They're not necessarily harder than these, but whatever, okay? And it's the same for each column. So number 4, here we go. D is dividing, I'm sorry, D is being divided by 6, okay? So you will do the opposite and you will multiply by 6. The opposite of division is multiplying, okay? These 6s cancel out. If you're not sure why they cancel out, then let me give you like a little what's happening. When you multiply by 6, you're really multiplying by 6 over 1. Anytime you have a whole number, you can write it as over 1. And it is multiplying, let me change it to white so it matches this, d over 6. When you multiply fractions, you go straight across. That would be 6d. That would be 6. And if you were doing this division, these 6s cancel out, leaving you with just d. So d equals -3 times 6, which is -18. So there's our answer. Let's check it real quick. So it was d divided by 6 equals -3, but we no longer need to call that d because we know that it is called -18. So if you had -18 divided by 6, that would be -3. And does that equal -6? It does, and we are happy. Number 7, 9.6 equals 1.2y. So just like number 1, these guys, I say these guys, this 1.2 is multiplying y. How do I know? There's no plus sign. There's no minus sign. There's no division sign. It's not like 1.2 over y or y over 1.2. That would represent all of those outcomes. So what we're going to do, I wish I hadn't drawn this squiggly purple line, is that we are going to divide by 1.2. Why are we doing that? Because that's the opposite of multiplying, and we're going to get y equals, well, you know what? If we do it to one side, we have to do it to the other. In fact, you might notice I haven't drawn like my signature. If you're like, well, his signature, what I was about to say is I haven't drawn my like line to say, hey, listen, there's a left side and a right side to the equation. I normally do that So let me go back and do that. There's a left side and a right side. This kind of made me draw through my 4, but you get the idea. Same thing here. There's a left side and a right side. And so what we're going to need to do here is, well, do some long division. There's other ways we could approach it, but I'm going to go ahead and do long division. Maybe we could say it's the box. But here we go. 1.2 divided by... 9.6 divided by 1.2, like that. Okay? I need to move this over here. I need to move this over here. Why are we moving those? Because we're not about to ask how much 1.2 multiplies to get 9.6. Instead, we're going to move that one. And if we move this one, we move this one. We're now going to ask, how many times can I multiply 12 to get 96? Okay, that seems a whole lot more reasonable, don't you think? So, how many times can we multiply 12 to get 96? Well, the answer is actually going to be pretty okay because it's 8, all right? 8 times 12, 8 times 12, 8 times 2 is 16, and 8 times 1 is 1. Add that, 8 times 1 is 8, add that 1 and you get 96. So it's just 8. So let's zoom back out here. Y equals 8. And what we can do is now plug that back in right here and check our answer. So does 9.6 equal 1.2 times 8? Well, if you're not sure, we just did 12 times 8 and got 96. So check this out. 1.2, the difference would be there's a decimal right there. And in the end, what happens is you'd move that decimal one place to be back to where it would be behind the number normally. And since we moved it once here, we move it once down here. And look, we get 9.6. So 9.6 is, yes, it is equal to 9.6. We did it. Number 7. Here's number 10. Negative 3/4 x equals 21 over 8x. I'm going to put a star next to this one, and I'm going to put the star back over here too. This one is the funky problem of the day. Congratulations, you're the funky problem of the day. So why is this the funky problem of the day? Because there are x's on both sides. Okay? And if you're like, oh man, that seems awful. Imagine we go back to the seesaw and we have a puppy over here. Oh man, I can't draw puppies. And yet I keep using puppies as the example. Here is our puppy. You know what? That looks like a cat. So it's a cat. Well, guys, there's a cat and then some weights. Well, what if there's a cat and some weights over here? Okay, well then take this cat and move them over here, and then we'll have both the cats over there, right? And if you're like, how exactly is this cats? Well, it's because we have the unknown, and the unknown of our seesaw problem was el gato, the kitty cats or the dogs, right? So here's what you're gonna do. You're going to move them over, and you know what? Honestly, maybe I should rewrite this one in class after you try it first. Maybe that's what I'll do. But anyway, here's what I'm going to do. I'm going to add 3/4 x to both sides. And here's what's happening. If you had negative 3/4 of x plus 3/4 of x, you would now have 0 altogether. 0. Okay? This is just like saying, hey, if I picked this cat up and moved him over here, I would now have 0 cats on this side of the seesaw, right? All right, so now we just have to do some fraction adding. Hooray! So we need a common denominator. The common denominator here is we're going to multiply the top and the bottom by 2 and get 6/8. And up here we had 21/8. Don't forget your x's, and we're adding. So what you're going to get is now 27 eighths times x. Well, you might be thinking, oh my goodness, how are we going to do this? But let's just do a couple things here. One, we could logic through this and go, this is a number we don't know what it is, times 27 eighths. And the result is 0. So that must mean that x is 0. Because if x is 0, then 0 times 27 eighths would give us 0. But if you are stubborn and don't want to do that, then here's what we're going to do. We're going to multiply by the reciprocal. Multiply by 8/27, multiply by 8/27. And if you're like, that's messing with my brain, that's okay. I can remind you how to deal with that, okay? What happens is multiplying by the reciprocal is the same as if we had decided to divide by that fraction. And if you're like getting dizzy because there's fraction, and ugly, just remember, this was multiplying, right? This was multiplying. We want to get this x by itself. So you would normally divide, but because fractions are a little on the unique side, we can recognize, hey, why don't we just multiply by the reciprocal? And guess what happens when you try to multiply 0 times 8/27? You'll never guess. You get 0. And now to check our answer, which you might think is going to be horrible, but 3/4 times 0, does that equal 21 eighths times 0? Well, that's 0, and that's 0. So does 0 equal 0? Yes. Okay. So now that funky problem of the day is out of the way, then let's do 13. 13 says 3k minus 2 equals 10. Well, on the left side, hang on, back up. Yeah, I did a left side, right side up there. Okay, I just wanted to double check myself. Left side, we have 3k minus 2. We cannot simplify that. In fact, that's what happened up here is this could be simplified. It could have been. So we needed to do that first. On all of these problems, you should be asking, can it be simplified first? And here's the thinking behind that. PEMDAS or GEMDAS, however you've learned it, this is the grouping, that's parentheses. This is exponents, multiplying, dividing, adding, subtracting. I did an S, subtracting. So, and if you're like, okay, why are we doing this again? These guys are in the same boat. Just as a reminder, these guys are in the same boat. If you interact with them, you need to just make sure and go left to right. That would be your best bet, go left to right. But why am I talking about this in general? Because earlier when I said that if we need to simplify, you simplify using PEMDAS. You always have. You would start right here, and then you would travel down, asking if you have multiplying, dividing, and whatnot, and then you would end up right here. But now that you have grown up in the ways of solving in math class, you now can start solving. And notice it starts here, underneath add and subtract, and it goes this direction. So what you're going to end up doing is asking, is there any addition and subtraction I can do first? Then, is there any multiplying and dividing I can do after that? And then, I'll just be honest with you, we're not going to run in to these last guys, not really, so you don't have to worry about them so much. But here's how you solve. You solve ... by doing the opposite. And that's what we've been talking about over and over and over, is that like up here, why did we divide by 15? Because that's the opposite of multiplying by 15, okay? So we're back here. We're asking, can that be simplified? And the answer is no. So then we're not going to simplify. We are ready to solve. And so we're going to start by asking, is there any adding or subtracting happening to the k? And the answer is, yeah, we are subtracting 2. So let's do the opposite and let's add 2. Let's add 2 to both sides, and you get 3k equals 12. All right? We now ask the question, what's happening to k? It's being multiplied, so we shall divide by 3. These 3's cancel, giving us k equals 4. And we can plug that back in to solve and check our answer. So let's do that. Let's do 3 times 4. Why 3 times 4? Because that's 3k. Minus 2, does that equal 10? Well, 3 times 4 is 12. 12 minus 2 is 10. Does 10 equal 10? It sure does. We're super happy. We did 13. Let's go to 16. Can this be simplified? The answer is no. So we're going to ask on the right side of the equation, because this 12, dude, that's simplified. And we're not going to solve. We're not trying to get d by itself there. But over here, is there any adding or subtracting happening to the d side of this? And the answer is yep. So we're going to do the opposite. So we subtract 3.2. See ya. Subtract 3.2. And by the way, so if you need to, you can hop over here and subtract like this. You line up your decimals, right? Like this decimal wasn't here, but we can add infinite zeros, a million bajillion zeros behind our decimal if we wanted to. So now we're subtracting, this is 11, that's 10, that's 8, and this is 8.8. So we get 8.8 equals 2d. What's happening to d? It is being multiplied. So we shall divide, and the 2's cancel, giving us that d equals, and I don't know if you can do this in your head or not. I know you can. You can do this in your head. 8 divided by 2 is 4. And then guess what? We have another 8. That divided by 2 is 4. The answer is, zooming on accident. The answer is 4.4. D equals 4.4. And now we can check our answer by plugging it all back in. 12 equals, hang on, let me zoom in. 12 equals 2 times 4.4 plus 3.2. Actually, I guess we're technically asking the question, does 12 equal all of that? And so let's go on. 12, do you equal 8.8 plus 3.2? Well, yeah, we just did it right there. That if you were to add 8.8 and 3.2, then that's what you'd get. So the answer is yes, 12 does equal 12. We're happy about that. And what we're also happy about is we're on the last one for day 1. I know it seems like I'm going to do a million bajillion problems, and so are you, but we're going to get through this, and you're going to feel like a math rock star. So here's our line. There's a left side, there's a right side. Can this side be simplified? You're going to find out a lot of the time. There's kind of no when it's fewer steps. I wanted to say shorter steps, but that didn't make as much sense as fewer steps. So guess what? We're going to ask, is there any adding or subtracting happening on the side of k? And the answer is yeah. And it's not just is there adding or subtracting happening, is it happening to the k? And yeah, we are adding 3.6 to that negative 4k. So now it goes away, and we need to make sure and do it on both sides. So now we have negative 4k equals 4.2. Not sure how I got that. 8 minus 6 is 2. 7 minus 3 is 4. Decimals lined up. Now, we need to continue to solve. So what's happening to k is it's being multiplied by negative 4. So we should divide by negative 4. So I'm going to come out over here and say, all right, 4.2. Let's divide you by negative 4. And we're not going to really get focused on the negative part right now. We're going to throw that on our answer. And we're really just going to ask, how many times can I multiply 4 to get 4? That's a tough one. It's 1 time. We subtract and we get 0. This 2 drops down. And 4 multiplies 0 times in order to get 2. So we subtract and we get another 2. But guess what? There's an invisible 0 that drops down here. And now we ask, how many times can 4 multiply to get 20? And the answer is 5. So that's our answer. K equals negative 1.05. And we can check that. In fact, here's kind of the funny part about this is we just did this little math here. So negative 4 times negative 1.05 is going to equal positive 4.2. And in fact, why is he mentioning this? Because that's what's happening right here when we check this answer. Okay? So let's go ahead and just write 4.2. If we add 3.6, do we get 7.8? And if you're wondering, why would we do that? Because that's what's happening here, right? So what's 4.2 plus 3.6? I don't know, let's stack them on top of each other and do the math. It's 7.8. Oh look, 7.8 equals 7.8. We're super happy about it. Day 1 is in the books, y'all. I know you might be thinking, holy cow, that's a 26.5-minute video to do 1, 2, 3, 4, 5, 6, 7 problems. Yeah, and I explained a lot as we did it, and honestly, the first 5-something minutes was me getting us ready to talk about this. So let me know what questions you have over day 1. Video of day 2 will show up soon. See you later.